welcome you all to this, we call it seminar or webinar, and whatever that is organized by the IALE-Europe. And I'm here today saying hi to you all because I am a member of the executive committee of IALE-Europe. And I'm sort of stand-in. So this is last minute because this was supposed to be done by our chair, Veerle van Entwelte, but unfortunately she couldn't make it today. And she asked me, which is not entirely random, because I'm actually the boss of today's speaker at the moment. So Ulrike Bayr, who is gonna give her talk today, she is a PhD student in my department, in the Department of Landscape Monitoring and the Division of Survey and Statistics and the Norwegian Institute of Bioeconomy Research. And Ulrike has been with us for quite some time because she did her master thesis as well. Also a very interesting landscape ecology theme, because then she worked with edges and looked at the definition of edges and how edges develop. But that's not the topic of today. Today, Ulrike is going to talk about widening the perspective in landscape monitoring with repeat landscape photography. And some of you may not be familiar with this idea of repeat landscape photography, which I'm sure that Ulrike will introduce you to. But we are in NIBIO, we work a lot with maps in our division and in my department with the monitoring, and I know many others do as well, aerial photos, map, satellite imagery, all sorts of sources that looks at the Earth from directly above. And we realized that there are many other sources of information about what goes on and the changes that is happening as well. And change is, after all, a very important theme in landscape ecology. So Ulrike has, among many other tasks that she's working on and helping us with, done several studies actually related to this use of aerial, on-the-ground photography as a data source also in landscape monitoring. So I'll leave it at that and say, Ulrike, floor is yours.
Thank you very much, Wenke. I think you have to make me a host before I can share.
I will quickly do that. And thank you, Wenke, for introducing our speaker today. Maybe now you can make me a host again so that I can manage the chat and the participants. It should work.
Wait. Yes, you still see the presentation?
Yes, yes. Thank you, Ulrike.
Perfect. Yes, hi everyone. Thanks for the introduction, Wenke. And I also want to thank Simona for inviting me to give this presentation today. It's a great pleasure. Yes, my name is Ulrike and I work as a PhD student in the Department of Landscape Monitoring. And wait, now. Before we start, I want to tell you a bit more about my PhD project. I'm enrolled at the University of Oslo, but I'm employed at NIBIO in Ås. It's a small town south of Oslo. And my PhD project is quite broad, as it also is with the field of landscape monitoring. As Wenke said, we capture quite a lot of different aspects and use different methods and data sources. So also my topic is very broad, but the main objective is to test quantitative methods, which can contribute in making landscape monitoring in Norway better, or to test new quantitative methods. So I focused quite a lot on landscape photographs because there is some gap to the other remote sensing data. So in quantifying these type of photographs. And I used some deep learning methods earlier during the project. And I now start also with machine learning on bird data. But today's topic will deal with the second one, with the use of monoplotting on landscape photographs. And that's a method that allows it to georeference photographs and to extract geographical information from that. So that's also the most recent topic I published in an article. So, but before we are going to this part, I first want to give you a short introduction to the landscape monitoring in Norway. We have a national monitoring program called the 3Q, and it's focusing on the agricultural landscape because we have quite we have very few areas that can be used for agriculture in the European context. And so it's very important to monitor these areas and to monitor the development of these areas. As said, we capture a lot of different aspects, of course, changes in land cover and landscape structure, but also single landscape elements like stone walls. We also monitor farmland birds, vascular plants, and also cultural heritage. A bit more on the methodology of the program. It's a sample-based program. So we have 1,000 of these monitoring squares distributed over the whole country. And here in the right corner, you can see one of these squares. It's 1 × 1 kilometer in size. And you see here the mapping. And we have a very detailed mapping in this case. It's over 90 different land cover classes, so that's quite detailed. So we do area photo interpretation on all of these squares to monitor changes in landscape structure and land cover. And we also have a subset of these squares where we do field registrations of birds and plants. And based on all this information we collect, we calculate a whole bunch of different indicators, also capturing the landscape heterogeneity, for example. But we do also another thing, and that's repeat photography. That's not very common in most other monitoring programs. What's that? That's the principal method is actually quite simple. You just retake a landscape photograph a second time from exactly the same location. But often in praxis, it becomes obvious that it's not that easy to get the exactly same view again. Perhaps you have heard about Mark Klett. He published a book called Second View, and that's one of the oldest or one of the first rephoto projects that have been done in the USA. And in Norway, we have our own project that's called Tilbakeblikk, flashback on English. And we have there over 4,000 image pairs today. So that's quite a lot. We use our own method to do these repeat photographs to find the original position. We use a grid overlay over the original photograph. I don't know if you see my mouse cursor actually, but
yes, we can.
Okay. This grid, it corresponds to the grid inside the camera. So if we are in the field and take a photograph, we can compare the crossing points here from these lines and use them as checkpoints. And if several of these checkpoints match the original photo, then we have found the right position. Because often in the field, it's very difficult actually to find the right position. And if you're only 1 meter from the original position, they are not matching any longer. So that's quite tricky in the field. We use these photographs in a systematic way inside the monitoring squares. So we collect metadata on direction and where we took them. But we also do an unsystematic approach outside the monitoring squares, because in the monitoring program, we are a bit locked from the time scale because the program started in 1998. So we do rephotographs from this time on. But the most interesting pictures are outside the monitoring program. These are the historical ones that cover quite large time periods. However, as I said, it's not very common to use landscape photographs in quantitative research, and it's for a good reason. If you look at the development of image sources throughout time, you see a very clear development from being very, very descriptive to being more quantitative data. And especially these data with the orthogonal view, also from the bird's eye view, the bird's eye perspective, they show the landscape in an undistorted way. They make it very easy to measure areas if you have aerial photographs and satellite images. So it's very advantageous to use these data sources for quantitative analysis. However, we still use landscape photographs in Norway. So you may ask, why should we do that? Is not an out-of-date technique? And yes, it's true, it's out of date, of course, compared to all these newer technologies. But on the other side, photographs have some very fine qualities, which make them very valuable for landscape research. And you can see it on this illustration. That's actually the main advantage of landscape photographs. They cover a much longer period in time. All these newer remote sensing techniques, they first appeared in the second half of the 19th century. But with the landscape photographs, we can extend this period by nearly 100 years. So that's quite valuable to get also the period before landscape, before aerial photographs became common. In addition, landscape photographs cover a lot of details. You can also see the vertical changes, for example, in the layering of vegetation. And as I also will show you today, they're very effective in communicating results and landscape-related topics. And the reason for this is very simple, because they show the landscape the same way as people naturally perceive it. So the perspective is here very relevant. If you just imagine if you give a random person on the street a pair of aerial photographs and ask them what happened, do you see the changes? Then you may wait quite some time before you get an answer. Because we are not used to see the landscape this way every day. And you need actually some experience in interpretation of aerial photographs to grasp what's happening. On the other side, if you give people a pair of photographs, of landscape photographs, then you see that they're getting very engaged and motivated, and they understand directly what's going on here. And we made the experience here in Norway that these pictures are quite attractive and very popular. So we do exhibitions with them, and also the newspapers use them. And they like to print them and write stories about landscape change. So it's very effective in engaging people to discuss and to reflect landscape changes. However, although we use these photographs quite a lot in Norway, we also a bit limited to qualitative use. We mainly use it to illustrate topics or changes, not really as a quantitative source. So that's the challenge, using these photographs for more than that, to use them for real quantitative research, getting numbers out of them. However, there's a reason why we have left landscape photography in landscape research and moved forward to aerial photographs and satellite imagery, because there are some challenges which make it difficult to quantify landscape photographs. First of all, we don't have any geographical information, the same way as we have in aerial photographs. They don't have any coordinates. Another big problem is the oblique perspective, which makes it difficult to measure areas, because the reality is distorted. You have the things in the foreground, they are much larger than things in the background. And you have also the problem of varying illumination and shadow cast. And finally, also vegetation that has grown up can hide things of the parts of the landscape. So it's not worth to quantify every landscape picture if it shows only a forest, so you cannot see the landscape behind. So there are quite a lot of challenges. However, there's one solution which makes it possible to quantify photographs and to use them as geographical data source. And this method is called monoplotting. Perhaps you have heard of stereo photogrammetry. It's when you have two overlapping aerial photographs and you use a stereoscope. These are some glasses. And you look at these overlapping pictures and you see the landscape in 3D. And if you have only one picture, you call it mono-photogrammetry, also monoplotting. And you cannot do this with common ArcGIS. They are not developed for this kind of image data. So researchers in Switzerland at the WSL Institute, the Swiss Institute for Forest, Snow and Landscape Research, they developed a great tool to do that. And it's very nice to use. They have a nice user interface. Not that easy in the beginning, but it's absolutely possible to manage if you have some background in geographical data analysis. And it's available for research freely. The basic principle for the monoplotting tool is that each single image pixel can be related to a real position in the real world, to a geographic address, a coordinate. You see the digital elevation model in the background, and each single point in the photograph has a real position on this elevation model. So what do we need to perform this monoplotting method? We need basically three things. The landscape photograph, of course. Then we need the elevation model with a high resolution. I used here 1 meter, which is recommended. And we need an ortho image, an aerial photograph of the same area. The next step is to select reference points. Perhaps you're familiar with the georeferencing in ArcGIS. It's a bit the same principle, that you find landmarks in the photograph, distinct landmarks, for example, house corners or piles, larger stones. And then you find the same position in the aerial photograph so that they're linked together. Because the aerial photograph has a coordinate system. And the aim is to translate these coordinates to the ground photograph. When you see in the background, it's the elevation model with the geographical information and the surface. So we need to define at least 5 of these reference points to calculate the rest of the image automatically. But before that, we have to do a camera calibration. That's part of the software. That's actually the tricky part. Because based on these reference points, the software tries to calculate all the camera parameters or try to reconstruct them It calculates the right focal length, or if the camera is rotated. It tries to calculate all these parameters. And aim is to solve this equation. And if this is successful, we can use the equation to calculate the geographic coordinates of all the other image pixels automatically. So we only have to define 5 points manually, and then the rest of the image is calculated automatically. After that, the image is georeferenced, and then we can directly draw polygons, and we can set points in the image and also measure distances. And we get area information from that. We now know how large these areas are in reality. And we can also export it to GIS to use it there with other data, and in the same way we would use common GIS data. So that's very comfortable, this method to use and to get this information out of these landscape photographs. However, there's one big question: how accurate are these geodata? And that's actually what I did in the paper. I performed an accuracy test on this data, on this extracted geodata. And I used 7 landscape photographs for that. I used newer photographs because the thing is, the method itself, it's mostly interesting for historical photographs from the time before aerial photography. But then we have the problem: we cannot prove or we cannot test the accuracy because it's the only image source. So we cannot compare it to aerial photographs because there are none. So we need to find out what's the error range, or what can we expect of analysis. What error can we expect from the geodata we extract from photographs? So I used newer photographs to compare them with aerial photographs from the same year. So what did I do? I mapped points on these photographs, several per image. And then I mapped also the same location on an aerial photograph. And then I compared them and calculated the difference between the points. Here you can see the results. Here you see the different photographs, and the mean displacement is 1.5 meters. So that's actually a good result. It's relatively accurate. So if you remember a satellite image from the newest Sentinel, it has 10-meter resolution per pixel. So 1.5 meters here is not that large error. So of course there's some variation. You see here one picture is a bit outlier. Has a lower accuracy, but most of the others fall into this range here, or this mean value. I did the same with polygons. Here I used polygon area and compared it between the terrestrial photograph and the aerial photograph. And here the results show that the difference in area is 5% on average. And it showed that polygons are a bit less accurate than points, of course, because single points, because a polygon consists of several points, and then you accumulate the error, and then you can expect larger errors here for that polygon than single points. However, 5%, that's not a very large difference. Of course, there are some influencing factors that affect accuracy. First of all, the accuracy of the elevation model, because that's the basis of the calculation. And if the terrain model is poorly resoluted, you will also get poor results. Another thing is the quality of the landscape photograph itself. If it has bad resolution or a lot of shadows, it's very difficult to mark the right point, the reference points. And that's perhaps a special thing for this monoplotting method. It's very sensitive to small inaccuracies in digitizing. So if you miss the right pixel with a few pixels, then you can cause very large displacements in the points you set. So it's very important to work precisely. And finally, also the angle of incidence is relevant. So I've seen in the test that images with a very low angle of incidence are less accurate than images with a high angle of incidence. That's somehow logical. If you think of aerial photographs, they usually have 90% angle, also a very high angle, and that's the reason why aerial photographs are very precise. But in some cases, when you take, for example, a photograph of a mountain side, then you can also reach very high angles, or almost the same angle as with an aerial photograph. So that's a very important factor that influence accuracy. Well, at the end, I want to leave all this technical stuff and just show you in a practical example what we can do with this method and which advantages we can gain from using the landscape photographs in research. So I want to show you an example from a Flysetra mountain farm. It's a mountain farm in a valley called Morid in the middle of Norway. It's part of Dovrefjell. It's a very popular hiking area in Norway. And it's also the only part in Norway you can see the Moskus ox. So very, very nice area here. And also in Norway, we believe the king of the trolls lived there under the mountain. So at least one of Norway's greatest writers, Henrik Ibsen, wrote a tale about it. Yes, so let's move to Flysetra mountain farm. You can see a repeat photograph of this farm. It's a bit difficult to see here on the old photograph, but it's here on the new one, you see it. And it's a very old photograph from 1937. And the farm was permanently inhabited until the second half of the 18th century. And after that, it was still used quite a lot for summer pasture farming. So the farmers went there with their animals and used the farm during the summer months for grazing. However, as it happened to many mountain farms in Norway and also the rest of Europe, also Flysetra has been abandoned in the 1950s. But yeah, also the mountain farm is abandoned, but there's still some grazing activity, but very, very extensive. So it's not enough to keep the valley sides open. So we see how the forest area has increased throughout the period. So I wanted to try to analyze this change using the landscape photograph. And the first thing I did was to search for remote sensing data, the oldest image data I could get. And the oldest aerial photograph I found was from 1971. So it's not very old, but it was the only one available for this area. I also choose a newer one from 2010. And we have the repeat photograph from 1937. So I tried to do the monoplotting here as well. And I got some problems with the old photograph, because usually when you do the monoplotting, you need an aerial photograph to find these reference points to relate to. And the time gap between the photograph here and the aerial photograph is quite large. It's almost 40 years. So it's very hard to find larger stones here in the aerial photograph because they disappeared on the shrubs and trees. So in this case, the use of repeat photography is a very huge advantage because they match perfectly each other. So we can define these reference points on the newer photograph. So that's what I did. I found these reference points on the newer repeat photograph and linked it to the newer aerial photograph from the same year, almost same year. And then I transferred these points to the old photograph. And that's only possible if the repeat photograph is very accurate and captured with very high precision. And yeah, finally I was able to map these forest areas here. I did the same on the area photographs and then looked what has changed. And here you see in this timeline the changes in the forest area here around Flysetra mountain farm. So quite a lot of changes here from the first landscape photograph until today. And I just want you to remember the mountain farm was abandoned 1950 around. So it's here in between. And if you only use remote sensing data, you have 20 years between the abandonment and the first photograph. You do not get the time when it was actively used. So it's quite a large time that is missing here. But by including the landscape photograph, you get also the stage before abandonment. So when it still was used for summer grazing. So actually the first two images or the first two stages are the most interesting one, because here a lot of things happened in the use of the area. That's a very simple example, but it demonstrates the advantage of including landscape photographs, because then we can expand the whole research period quite a lot back in time. Another nice thing with the monoplotting method is that we can transfer, reproject the mapped areas, for example, mapped areas from the aerial photographs, back on top of the photograph, on the landscape photograph. So we can show the results directly on the photograph. Of course, we can always draw it by hand, but then if we would do it without monoplotting, we only get these lines, but not the data on change. And that was monoplotting allows us to extract the quantitative information, the area information from the photograph. That's very effective in communicating the results to a very broad audience. Yes, I've come to the end, but to summarize what I told you, we have seen that monoplotting is quite a good technique to extract geographical data from these landscape photographs, and it allows us to quantify landscape dynamics and also to go very far back in time for that. And also we saw that it's a big advantage of combining landscape photographs with newer remote sensing data, because they supplement each other very well with different type of information and different perspectives. So they are not a substitute, but a supplement to each other. And finally, last but not least, we saw that landscape photographs are very powerful in communicating landscape dynamics and also research results to to a broad audience, actually. And I think especially the last point is very important to keep in mind, because our ambition as researchers is not only to write a bunch of papers, perhaps only a few colleagues read at the end, but it's also to spread the knowledge to as many people as possible, and also to decision makers and the general public. So I wish we could use landscape photographs also in the future, because they are quite valuable for landscapes research, and also to raise awareness about landscape dynamics. Yes, and with that, I want to say thank you very much for listening.
Thank you, Ulrike. It was a very nice presentation. I keep getting amazed about what is actually possible. And I think that from a landscape ecology perspective, being able to extend the time scale in the monitoring of dynamics and change has a lot of potential, given that continuity is also something that we are indeed concerned with, and that may matter to species diversity on a location, for instance. So, Simona, I don't know, should we ask if there are any other questions that someone would like to raise? Or?
Sure. We encourage you either to address them yourself or write them in the chat. I also have some, so maybe I can start until people write prepare their questions. I concur with you, Wenche, regarding this ability to extend the timeline and look further back in time at landscape changes. And I was curious, Ulrike, you talked about pasture abandonment and how vegetation changed in that area. I was wondering if you looked at other type of landscape transformations besides abandonment.
Not in this case, no. It was only to demonstrate the practical use, but it was not meant to analyze the different aspects or different causes of this encroachment, for example.
Mm-hmm.
So,
do you generally look at, or you focus on the technical part and improving that, or okay, so not necessarily
right,
understanding, like having an in-depth study in the various cases that you looked at.
No, that's right. I focused on measuring this, the accuracy for our data material. I think, Wenche, you have to. Yeah.
Oh, okay. Yeah.
No, but there are some other studies that used, also the monoplotting tool is not new. It has been used before by other researchers, and a lot of them used it also more thematically to analyze, for example, ecological changes. But for me, it was important to test it on the Norwegian material, because I saw that the image, the image source is a bit different. As people in the USA, they use some data from the national park there, and the photographs, of course, it's also landscape photographs, but they are taken, for example, on a higher elevation, and they cover a larger part of it. So the accuracy depends very strongly on the material you use, on the photographic, on the content of the photographs.
Yeah.
Sorry if you all heard me move about. My internet connection fell out. I tried to mute and carry my computer at the same time, which obviously didn't work that well. You have a question in the chat as
yes.
well, Ulrike.
Should I read it?
Yes, please do.
Okay. It's a question from Maria Kilaku. She's a PhD student at the University of Athens in the Department of Geography, and asking, when using historical photographs with monoplotting, did you have a historical digital elevation tool, or there wasn't any topographic differences in the area? Because this is the biggest problem that Maria has when working with historical photographs.
Yeah, I agree with that. That's a big problem. I did not use historical elevation models because they are not available actually for this time period. So yeah, you have to rely on the newer ones, and but where you can give a measure on this vertical accuracy of the dam, but it's hard to measure to validate it for the historical stage. So that's right, and I've not yet come to a solution how to overcome this problem. So because in Norway we don't have these historical data sets available. So yeah.
Oh, I assume this is
I
quite.
suppose it would be an own article to find out about that.
Regarding the digital elevation model, I was wondering what would be the minimum resolution recommended to be used. You mentioned, I think, a meter for the one you used, but for example, if one would use other resolution, 5 meters or 10 meters, how would that affect the results?
I actually did a test with a 10-meter resolution. How large is the error when I use 10-meter resolution? And it's still possible to do, but then you have to expect about double. The error is doubling around. So it's recommended if you have to use 1 meter. It's also the developers of the tool recommend 1 meter. So.
And what would be let's say a practical advice for people working with these photographers in selecting landmarks? I mean, I assume it's quite easy to do it if there are buildings or you mentioned rocks, bigger rocks, but is it challenging to work with photographs where it's mainly a natural landscape with vegetation, which we know is changing? Like, what other landmarks you use, or how you proceed with that?
Well, in the beginning, it's perhaps a bit difficult because you need to first find out what works and what works not. But I think it's after you have found some points, you can always correct afterwards. So you can also choose other ones if you find points that do not work. But I've found it easiest to use, for example, road crossings. They are usually often very, very consistent in the landscape. And also, yeah, building corners are also very good points. One thing I saw was a bit problematic when you choose points close to ridges or on the top of a hill, because when you miss the point, then you can go beyond the hill and get a very, very huge displacement over hundreds of meters in the measurement, because the point is not hitting the top of the hill, but it's displaced very far backwards.
Maybe that is linked to what Maria was saying earlier, like changes in the terrain. I assume that if one wants to map an area where there are a lot of landslides, then that should be even more challenging.
Right. Yeah.
I think one should. I have seen something similar used to to monitor the development of gullies, though. In landscapes, they were exposed to this gully development, where they actually used it to measure how also the terrain changed, because they had these points that they could use. But so that was also a very interesting study I found. But Ulrike, a question: have you thought about the possibility to use these to look at, for instance, climate change effects in terms of tree line, for instance, over a long extended period of time? Do you know if that could be, I mean, how the tree line keeps climbing up due to climate change? Do you think that could be also a use somewhere, and what do you call it, an application or a way where something where this could be useful?
Yeah, I think in general, mountainous areas are very well suited for this method, because then you have often this very high angle of incidence, which increases accuracy, because when you have very flat landscapes, it's often more prone to inaccuracies and higher errors. But I think actually this would be a nice analysis, yeah. Because I think also mountainous areas have been quite popular in the time before to take photographs of. So I think the available image sources are quite rich. Yeah.
Yeah, that's I would imagine that that's a good point, at least for Norway, where we have the very early tourists that were English aristocracy that came to visit the wild. But,
the only issue perhaps may arise in these natural mountain landscapes. It becomes very difficult to find these reference points, because I saw the best or the easiest reference points to identify are these human-made or things, house corners and roads and piles, like this stuff. And these natural rocks are often very difficult to find the exactly right rock in the aerial photograph, and as shown in the photograph. So yeah, and vegetation has changed quite a lot, so you perhaps may not be able to use single trees.
Yeah, I think it's interesting, because as our photographer has said many times, he sort of finds these old photographs and then he sets about to take the new one, which is what is presented. A selection of these are presented in what Ulrike mentioned, which is Tilbakeblick. And maybe Ulrike, you could, or we should add in the chat the link to this website. But what he commonly experiences is that people say, no, it's always been like this. You know, yes, oh yes, even for a church tower, I remember he said that, but in my image from, I don't know, 1895 or something, this tower has to be in a different place. No, always been like this. It turned out that it had actually been taken down and rebuilt slightly in a different location. So man's memory is not really as reliable when it comes to how things were and what has actually changed.
In the chat, Maria was suggesting that historical maps may help there too. So indeed, to show how the landscape has changed and to highlight the differences. A combination of photography and historical maps may indeed be very useful.
I think that, I mean, a combination of sources is typically combining old maps, old photographs, old records of what has happened, the written records can also be useful. So to really sort of understand what is the case for this particular area that you're looking at or interested in. And I think also that with a word of warning in this respect, though, is of course that these are points in time on a long time axis. And we know that they were like this at a period, at some time, long time ago. We don't really know what has happened in between. And it may have changed and changed again. So that's, of course, also important to remember. But we have seen some examples where fields, for instance, have exactly the same shape, you know, over a period of 100 years, for instance. So, yeah. But it helps us understand landscape change and landscape development. And then, of course, driving forces, effects. There are many studies to do related to this, to follow up.
Yeah, I was wondering, I mean, Ulrike, where did you get the photographs from?
Do you mean the old photographs, or?
Yes, yes. I mean, is there a record in Norway of that, repository, or how do you obtain the material to study?
Well, they come from quite different sources. Also, the images within the monitoring program, we took the first pictures ourselves, of course, but the historical pictures, they come from private persons. There are a lot of people sitting on very huge amounts of private photographs from their ancestors. And we also get them from museums and public archives, the National Archive or National Library in Norway.
And old postcards.
Yeah, right.
The very, very first postcards that were made were typically these sites that or places in the landscape that a lot of people visited, because that's what people wanted to send home, you know, with a greeting. They've been to Norway and we've been to see this waterfall, or we've been to this mountaintop, or whatever. So old postcards was also an initial source of imagery. But many of these type of imagery, well, I think that what I've seen before is that some of these early explorers or early mappers, they also took photographs. So it's surprising in national archives, they are typically stored, what you can find. Yeah, if you find the right person to ask, or someone that can help you get through the archives, that's usually necessary.
Point to the coolest photographs. I think we have no further questions in the chat. I think we can slowly close the webinar of today.
Could you say maybe a little bit about the next? What are the plans, Simona, for continuing this webinar series? What frequency are we aiming for? Have we got a decision on that? Do you remember? I just can't remember.
Yes, we are now in debates to have it monthly. To mix more scientific presentations of the young researchers with other aspects of interest to young researchers. We are planning to organize a webinar dedicated to how to prepare for a job interview in academia, maybe applying for a PhD position somewhere, or a postdoc position. But we still need to receive the confirmation from the speakers. And later on, maybe somewhere in autumn, we will have a session dedicated to editors or landscape-oriented journals. Meet the editor webinar. So for the moment, we haven't prepared anything for the website, but as soon as we have the confirmation, we will upload everything on IALE-Europe website and post it on Facebook and Twitter.
So I must admit I took a photo earlier too. So this webinar is already on Twitter.
Okay.
I had to. Okay, so the message then to everyone is basically stay tuned, pay attention to what shows up on the IALE-Europe website and our Twitter account and other social media accounts, and you will get information about what's coming next. And of course, I mean, if someone has some suggestions, are we very open to suggestions as well, aren't we, Simona, about something that they think would be a really good idea, maybe someone you've heard talk or something you really would like to hear about. So that's also something we should invite.
Exactly. We are waiting for proposals for speakers, so don't hesitate to write us.
Okay.
And for today, we thank Ulrike. Thank you, Ulrike, for the nice presentation. And of course, we wish you good luck with your PhD research.
Thank you very much, and thank you for having me.
Thank you, and have a nice evening, everyone.
Thank you.